Alright, this question says determine the force, so we know we're looking for F, that is required to accelerate a 10 kilogram mass from rest to 10 meters per second over the course of 100 meters. Now, we actually did some very similar questions to this when we were talking about dynamics. So you can actually solve this multiple ways. You can actually say, okay, well, I've got F and I've got M, and I can solve for A, and once I have A, I've got VI, I've got VF, and I can figure it out from there. But you can actually do it all in one step, and by doing that you can use the work energy theorem, which says work is equal to the change in kinetic energy, or force times distance is equal to 1/2 of m Vf squared minus Vi squared. So we actually have the mass this time, so we can say that the mass is 10 kilograms. We can say that the initial velocity is 0. We can say that the final velocity is 10 meters per second. And we can also say that we have a distance of 100 meters. So when we look at this, we can say we are trying to solve for the force. So what I'm going to do is I'm going to take this D, I'm going to move it to the other side. In moving it to the other side, I actually have to divide both sides by D. So what I'm going to end up with is M Vf squared minus Vi squared over 2D. Okay, once again, you should recognize this. This right here, we learned before, is Vf squared minus Vi squared over 2D is really A, or the acceleration. So, but for now we have it all in one step, and we can say that F is equal to 10 squared minus 0 squared over 100. So we have 10 times 10 squared minus 0 squared, so this is just 100 minus 0. 100 times 10 is 1,000. 1,000 divided by 100 is 10. And then 10 divided by 2 would be 5. If you're not comfortable with that mental math, we can go ahead and plug it into the calculator. We can say 10 times 10 squared divided by 2 times 100. And we get 5 newtons. Now, once you realize this, this is the exact same thing that we talked about before. You could use Newton's laws, Newton's second law, F equals ma, and the kinematics formula equation, A equals Vf squared minus Vi squared over 2D. There's multiple ways to solve these problems. So although I'm trying to show you the one that's relevant towards conservation of energy, any solution that works for stuff that we have covered will work.